Okay, so welcome everybody. Here's our next kind of picture lab tricky 2D array manipulation. Go ahead and click on Picture Tester, and we're going to pull down to one called Test Edge Detection, which is the last one. And look, here's a lovely picture of a swan. Right? And ignore this kind of silly error message that always comes up. So if you think about most images at all, most pixels around in this region are always sort of the same color, this kind of grayish color. And most pixels around here are sort of the same color because the swans are white. There's some cases where actually the pixels actually are dramatically different in color than the ones next to them. Over here, most pixels are pretty close in color to the ones next to them. Here, they're pretty close in color to the one next to them. But right about here, this is the case where the pixels have a dramatic difference in color next to the pixels next to them. That's because there's an edge there, right? This is the border between the swan and the water, right? So what we're going to do now is we're going to basically write a method, excuse me, that is called edge detection. So it's going to basically detect where the edges are by looking for pixels that are different in color than the ones next to them. So it turns out the first question we want to think about is, and I actually have a little image right here, this is actually a little bit about edge detection. So here's the picture of the swan I just showed you. Here's what we're going for a little bit. See how it's kind of detecting the edges of the swan. When you think about like how far apart colors are, that's kind of a weird question to think about. So look right here. The formula for the distance between 2 points is, of course, the Pythagorean distance formula, right? Just x1 squared minus x2 squared or whatever. We're actually going to think of, if you think about a color as a red, green, blue, and another color is a red, green, blue, we're essentially going to have a method called color distance, which is kind of the Pythagorean distance between the reds, difference in the reds squared, difference in the green squared, difference in the blue squares all squared. It's kind of a different way to think about how far apart colors are, right? This is how far apart, square root of this is how far apart points are, square root of this is how far apart colors are, okay? So here we go. We're going to try to write some edge detection stuff. So let's go into Picture Tester. This will not come, as soon as we comment this out, it will suddenly no longer compile. Notice the edge detection method takes a parameter which is this 10 here. We're going to call that the threshold. That's how far apart 2 pixels have to be in color before it's considered an edge. So this won't compile. Oh no, we have to write edge detection. Let's go. So we're going to go into the picture class. We're going to scroll down here. This is right after what we just wrote, the create collage method. Public void edge detection. Again, unlike the other one, this takes a parameter int threshold, which is how far apart you have to be considered an edge. Well, let's start off getting a 2D array of pixels. So pixel, 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 bracket, 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 grid is equal to get pixels 2D. Now we have all the pixels. And here it's much less complicated than that collage one, so we can just start looping. For int r equals 0, r is less than grid.length, r plus plus, our standard 2D for loop, and c equals 0, c is less than grid bracket 0 dot length, c plus plus. And now we're going to write it's kind of a complicated one, is this pixel's color close to or far away the pixel to the right of it, we're going to say. So if, first of all, let's kind of break this down a little bit. Pixel is a 2D, sorry, not pixel, what am I doing? Grid. Grid is a 2D array of pixels. So grid bracket RC is 1 pixel, right? That's the pixel class. Dot, and it turns out there's a method called color distance. We're going to pick the first one. And you'll notice it's saying, give me a color there. So what I'm going to put right there is the color of the pixel to the right of it. What am I doing? Grid, bracket R, bracket C plus 1. That's a pixel, but this method requires a color. So dot get color. And we want to see if this crazy number is greater than the threshold. Okay. Now you notice right away, see how I put bracket C plus 1 here? That's checking the pixel to the right of it. So that's suggesting you which one doesn't have a pixel to the right of it? Well, the last one. So once you put a bracket C plus 1, you have to go up here and make that minus 1. We've seen that several times. So if it's bigger than threshold, guess what? It's an edge. So let's say grid, bracket R, bracket C, set this pixel set color, color dot black. Else, grid bracket R bracket C dot set color, color dot white. And guess what? Unlike that crazy collage one, I think we're done. I think that's the whole thing you need to do edge detection. So let's compile this. Okay, that's the whole thing. I'm going to go over here to Picture Tester. Picture Tester should now compile because we wrote edge detection. Let's right-click on Picture Tester, test edge detection, and there we go. Now, a couple comments about this. Okay, we set the threshold to be 10. One thing you might want to do is change that threshold to be like 20 or 5 and kind of see actually how it changes. Also, notice we said it's an edge if it has a difference to the one to the right of it, okay? Which is, if we only notice kind of down here, we know there is an edge, but because we're checking the one to the right of it, it kind of loses this bottom edge, because really there, the ones to the right of it are pretty close. It's the ones that are up and down that are different. So a more sophisticated edge detection algorithm might actually check both right and left or up and down, or you can change this as just changing it to up and down and see what it might look like. This is a very simple edge detection idea, but you can kind of play around with it a little bit, but it does do a pretty good job of actually finding the edges. And I'll let you play around with changing it to maybe be up and down, or up and down and right and left is pretty complicated. Or in playing with that threshold over here, like, oh, let's see, what if you change this to be, I don't know, 20? And one thing I kind of like to do is actually go in here and say, let me explore the swan, then edge detection, and then explore it again. So now it'll actually show the swan, edge detection 20, and then it shows you that. It's kind of a neat thing to now you can actually have both pictures and look at them together. And that's it. Great, thank you.